Hello everyone. In previous lecture, we had discussed different particle sizes of the soil and consistency of soil, and also the different state of soil like liquid, plastic, semi-solid, solid, and Atterberg limit or consistency limit, and also the graph which shows the details of the different state of the soil with its limits. So in today's lecture we are going to discuss all the limits one by one. So first one is the liquid limit. Notation is WL or LL. So it is the water content corresponding to the arbitrary limit between liquid and plastic state of the consistency of a soil as shown in the figure. Liquid limit. This is the liquid limit, which is the water content between the liquid state of the soil and the plastic state of the soil. So it is defined as the minimum water content at which the soil is still in the liquid state but has a small shearing strength against flowing, which can be measured by standard available means. So this is the definition of liquid limit. And with the reference to the standard liquid limit device, it is defined as the minimum water content at which a part of soil cut by a groove of standard dimension will flow together for a distance of 12 mm under an impact of 25 blows in the device. So this also definition based on the liquid limit device or reference to the standard liquid limit device. Then need and scope of liquid limit. Why it is necessary to determine the liquid limit of soil. So liquid limit is significant to know the stress history and different properties of the soil which is necessary for the construction. So from the results of liquid limit, the compression index may be estimated, and the compression index value will help us in settlement analysis. So if the natural moisture content of soil is closer to liquid limit, the soil can be considered as soft. If the moisture content is lesser than the liquid limit, the soil can be considered as brittle and stiffer. So these are the need and scope of the liquid limit. Then the test procedure. So the liquid limit is determined in the laboratory with the help of the standard liquid limit apparatus, which is designed by Casagrandes. And this device is known as Casagrandes liquid limit device as shown here. So let us discuss. First is the apparatus required: weighing balance, Casagrandes liquid limit device, grooving tool, then mixing dishes, spatula, electrical oven, squeeze bottle. So these are the basic apparatus which we require to determine the liquid limit of soil sample. Here the figure shows this is the Casagrandes apparatus liquid limit device. Here the specimen soil, this is the grooving tool, this is the spatula. With the help of this spatula we mix the soil with water, and these are the moisture cans which are used to determine the water content, in which we have to put some soil sample to put within the oven for determination of moisture content or water content. And this is the oven, hot air oven, thermostatically controlled with interior of non-corroding material, this material to maintain the temperature around 105 degree centigrade and 110 degree centigrade. So this is the oven. And particularly this Casagrandes apparatus consists of a hard rubber base of VS hardness 21 to 25, over which a brass cup drops through a desired height. The brass cup, this is the brass cup as shown here. This is the brass cup, this is the handle, this is the handle, this is the brass cup. The brass cup can be raised and lowered to fall on the rubber base with the help of a cam operated by a handle. This is the handle which we have to rotate manually. The height of fall of the cup can be adjusted with the help of adjusting screws. And before starting the test, the height of fall of the cup is adjusted to 1 centimeter. And also two types of grooving tools are used basically. One is the Casagrande's tool, another one is ASTM tool. And so the Casagrande tool cuts a groove of size 2 mm wide at the bottom and 11 mm wide at the top and 8 mm high, while the ASTM tool cuts a groove 2 mm wide at the bottom, 13.6 mm at the top and 10 mm deep. And the ASTM tool is used only for more sandy soils, where the Casagrande tools tends to tear the sides of the groove. So as per our requirement, we use the grooving tool. This is a grooving tool. So as per our requirement, we choose anyone. Next is the test procedure. So first is about 250 gram, or we can also take 120 gram of air dried soil passed through 425 micron IS sieve into an evaporating dish. And we have to add distilled water into the soil and mix it thoroughly to form uniform paste. Here like this, here we have to put the soil sample which is passed through 425 micron IS sieve. We can take 250 gram of soil, air dried soil, also we can take 120 gram of soil. As per our requirement, we can take. And we have to add distilled water with it, not the tap water. We have to add distilled water. Then place a portion of the paste in the cup of liquilimi device here, in this cup, and spread it with a few strokes of spatula. So we have to plane it like this as shown in this figure with the help of this spatula. Then trim it to a depth of 1 centimeter at the point of maximum thickness and return excess of soil to the dish. So we have to cut it like this, figure C, like this. We have to cut with the help of a grooving tool. We have to cut it. Using the grooving tool, cut a groove along the center line of soil in the cup so that clean sharp groove of proper dimension like 11 mm wide at the top, 2 mm at bottom and 8 mm deep is formed. Then lift and drop the cup by turning crank at the rate of 2 revolutions per second, this handle, second, until the two halves of the soil cake come in contact with each other for a length of about 13 mm by flow only, and record the number of blows, that is N. We have to record this, that in how much revolution the soil can mix up, like this in the figure D. Initial, this is the figure C. After cutting it, there is a plain cutting which is shown clearly here, and after rotation the soils, but the cake or pieces of the soil mix here. Then take a representative portion of soil from the cup for moisture content determination, and nearly after recording the number of blows, approximately 10 gram of soil from near the closed groove is taken for water content determination. Since it is difficult to adjust the water content precisely equal to the liquid limit when the groups should close in 25 blows. So the liquid limit is determined by plotting a graph between number of blows as abscissa on a logarithmic scale and the corresponding water content as ordinate. And repeat the test with different moisture content at least 4 more times for blows between 10 to 40. And then after repetition of the test, we have to take the average one. So this is all about the liquid limit procedure. In next lecture, again we will discuss about the plastic limit and also its laboratory test. How we can determine the plastic limit in the laboratory. So for this lecture, this much. Thank you.